Hello everyone, and welcome. Tonight, we're going to take a calm journey into the quiet mysteries of the cosmos. A journey where science and wonder meet in the stillness of the night, where the universe itself becomes a storyteller, speaking not in words, but in faint signals carried across unimaginable distances. NASA has spent decades listening to the skies, tuning giant radio dishes toward the stars. What they hear is often ordinary, the steady hum of the cosmos, the familiar patterns of planets and stars. But every now and then, something different appears. A sound that does not quite belong, a pulse too sharp to ignore, or a pattern that sparks quiet curiosity. These are the mysterious signals that stir the imagination. They are not frightening, nor are they loud. They are delicate, fleeting, and filled with possibility. Each one feels like a whisper from the universe, a reminder that we are surrounded by secrets still waiting to be uncovered. They arrive without warning, and sometimes without explanation, leaving behind a gentle trail of wonder. Tonight, we'll explore some of the most intriguing of these signals recorded over the years. Signals that have puzzled scientists, inspired dreamers, and reminded us that the universe is far larger and stranger than we can fully understand. So, as you listen, let your body relax and your mind drift. You don't need to solve the mysteries or hold on to the details. Just let the calm voices of space guide you deeper into the night, as we fall asleep to the mysterious alien signals recorded by NASA. Chapter 1. The Wow Signal. 1977. The night was still and heavy, the kind of summer night in Ohio where the air feels almost too warm to breathe and the only movement comes from the hum of insects in the grass. The Big Ear radio telescope stood like a giant steel sentinel, its broad surface stretched out across the fields, patient and silent, listening to the cosmos. Most nights were uneventful. The telescope gathered the steady static of the universe, long columns of numbers spilling across paper in endless rows. To most, it looked meaningless. To the trained eyes of astronomers, it was the slow heartbeat of the cosmos. On August 15th, 1977, that quiet routine was interrupted. Somewhere in the sweep of sky near the constellation Sagittarius, the telescope caught something extraordinary, a signal, strong, clear, sharp, and utterly unlike the noise that usually filled the recordings. It lasted 72 seconds, exactly the length of time the telescope could listen to one patch of sky before Earth's rotation moved it away. In those 72 seconds, something unusual spoke across the void. When astronomer Jerry Eman reviewed the data a few days later, he stopped cold. On the page, rows of numbers rose and fell in their usual hum. Then came the anomaly, a sequence of letters and numbers that jumped dramatically higher than the rest. It was precise, narrow, and unmistakable. He grabbed a red pen, circled the strange spike, and in the margin scrawled one word without hesitation: Wow. That quick mark would immortalize the signal forever. The Wow signal, as it came to be known, was unlike anything ever captured before or since. No ordinary celestial event explained it. It came from a narrow range of frequencies, the so-called hydrogen line, where natural cosmic radio noise is faintest. Hydrogen, the most abundant element in the universe, was thought by many scientists to be a natural meeting place for interstellar communication. If any civilization wanted to be found, they would likely send a signal there. That was precisely where this signal appeared. The telescope itself was designed in a way that gave the signal its fleeting nature. The Big Ear did not turn. It was fixed to the ground, relying on Earth's slow spin to drift the stars across its listening field. Because of this, no source could remain in its hearing for more than a few minutes. The Wow signal matched this perfectly, peaking for 72 seconds before fading away. It was as though something passed directly across the telescope's line of hearing, a brief alignment that would never repeat. For decades, scientists tried to find an explanation. Could it have been a satellite? No. None matched the timing or the frequency. Could it have been a reflection of a terrestrial signal bouncing oddly through the atmosphere? No known source lined up with the data. The more skeptics tried to dismiss it, the more firmly the mystery held. The wow signal refused to fit into any easy category. It was neither ordinary static nor explained interference. It was something else, sharp and intentional in a way that defied coincidence. Some believed it was a deliberate call, a message broadcast across the stars and caught for only a fleeting moment. If so, the implications were staggering. A voice from 120 light-years away had crossed the gulf of space, only to brush past our ears for less than 2 minutes. Others thought it might be a natural cosmic event, some unknown astrophysical phenomenon that just happened to mimic the shape of an intelligent broadcast. But no other such event has ever been seen. The haunting part of the wow signal is its silence. Despite years of follow-up searches, no repetition has ever been found. Modern telescopes, vastly more powerful than the Big Ear, have listened to the same patch of sky again and again. They have found nothing. It remains a singular moment, suspended in time, like a word whispered once and never repeated. For astronomers, the wow signal became something more than data. It became a symbol of both hope and frustration. Hope, because it hinted that the universe might not be empty, that intelligence could exist out there. Frustration, because it came only once, with no way to confirm or deny its origin. Students still study the old printout, the red circle, the word wow pressed into the margin with the pressure of a hurried hand. Was it a call meant for us, or a fleeting accident of nature? Was it the first sign that we are not alone, or just the universe teasing us with coincidence? No one knows. What is certain is this. On a warm night in 1977, for 72 unforgettable seconds, humanity heard something that did not sound like the ordinary hum of space. It was louder, clearer, and sharper than anything before. And in that moment, with pen to paper, Jerry Emmon gave us the only reaction that felt right. Wow. Chapter 2, Voyager's Golden Whisper. 1977. The year was 1977, a time when Earth itself seemed restless. Cold War tensions divided nations. Technology was leaping forward in fits and starts, and the dream of exploring the cosmos had not yet dimmed from the glow of the Apollo moon landings. It was in this atmosphere that NASA prepared to launch 2 spacecraft unlike any before. Their mission was bold, almost impossible in its ambition: to leave Earth, travel past the outer planets, and then drift endlessly into the great beyond. Their names would become legend: Voyager 1 and Voyager 2. Each spacecraft carried scientific instruments, cameras, sensors, and antennas designed to send back data about the giant planets and their moons. But hidden inside their frames, bolted carefully to the side of each craft, was something far more symbolic: a golden record. A phonograph disc made of gold-plated copper, etched with voices, music, and images of Earth. If any intelligent beings ever found the Voyager probes, this record would be humanity's message in a bottle. Carl Sagan and his team at Cornell University had labored over the contents of the record, knowing they were creating what might be humanity's first deliberate introduction to the stars. They included greetings in 55 languages, from Akkadian, spoken 6,000 years ago, to modern English. They included sounds of nature, the rolling crash of thunder, the quiet whisper of wind, the cry of a baby, the laughter of children. They added music from across cultures: Bach and Beethoven, alongside Chuck Berry, Peruvian panpipes beside Senegalese drumming. To hold the record was to hold a time capsule of Earth's spirit. On August 20th, 1977, Voyager 2 launched first from Cape Canaveral, followed by Voyager 1 on September 5th. Their rockets ignited against the Florida sky, carrying the delicate machines higher and higher until they slipped free of Earth's pull. As the last stages of the boosters fell away, the Voyagers became wanderers, guided only by gravity and the careful calculations of mission control. Back on Earth, giant radio dishes tilted skyward. The Deep Space Network, with stations in California, Spain, and Australia, was tasked with listening. The Voyager's antennas, just over 3.5 meters wide, sent faint whispers back to Earth. Each signal traveled at the speed of light, taking hours to reach its destination. By the time those signals arrived, they were unimaginably weak, so faint they carried less power than a single household light bulb spread across millions of miles. And yet, NASA's receivers could hear them. The Voyagers' voices were steady, precise, and alive. As the years passed, the Voyagers fulfilled their primary mission. Voyager 1 swept past Jupiter in 1979, capturing breathtaking images of its swirling storms and volcanic moons. Voyager 2 followed, revealing details of Saturn, Uranus, and Neptune. They uncovered mysteries that no telescope on Earth could resolve: lightning on gas giants, strange magnetic fields, and frozen moons with hidden oceans. Each discovery rewrote textbooks, but beyond the science, there was always the golden record. The very idea that these spacecraft carried humanity's greetings stirred the imagination. Somewhere in their long voyage, they would drift into interstellar space, carrying with them a message meant not for us, but for them, whoever they might be. To think of it was to imagine a future encounter far beyond our own lives, a moment when another civilization might touch the golden disk, place a stylus to its surface, and hear Earth's heartbeat for the first time. In September 2013, NASA confirmed that Voyager 1 had passed into interstellar space. It had crossed the heliopause, the boundary where the solar wind yields to the thin plasma between stars. Its signal, weaker than the faintest candle flicker across a continent, still reached us. It was a milestone not only for science, but for humanity's imagination. For the first time, a human creation had left the cradle of the sun and stepped into the vast dark between stars. Even today, decades later, the Voyagers continue to whisper. Their power supplies are fading, their instruments shutting down one by one, yet their antennas still send home faint signals. Each transmission is a reminder. They are still out there, still alive, still carrying our message. The golden records remain bolted to their sides, silent for now, waiting. They may drift untouched for billions of years, longer than all of human history combined. Long after Earth has changed, long after cities have crumbled and oceans shifted, Voyager will continue its journey. It will wander through the galaxy like a silent ambassador, carrying the laughter of children, the sound of rain, the music of Beethoven, and the voice of a young woman saying simply, "Hello from the children of planet Earth." It is easy to think of the Voyagers as machines, but in truth they became more. They became symbols of hope, endurance, and connection. They are humanity's whisper into the cosmic dark, a whisper carried not on paper, not in stone but in gold, meant for ears we may never know. And so, in 1977, when those rockets left Earth's gravity, they carried not just instruments and metal, but the fragile, golden story of who we are. Chapter 3. The Pioneer Anomaly, 1980s. The story begins in the 1980s, though its roots stretch back even further. NASA's Pioneer 10 and Pioneer 11 spacecraft had already accomplished feats once thought impossible. Launched in the early 1970s, they were the first human-made objects to venture through the asteroid belt and capture close-up images of Jupiter and Saturn. Their missions had been triumphant, yet it was what happened long after the headlines faded that sparked one of the strangest mysteries in space exploration. As the spacecraft drifted away from the familiar planets, their transmissions continued. Each carried a small radio transmitter, tirelessly sending a faint stream of data back to Earth. For decades, the Deep Space Network tracked them, listening to signals so weak they were like the echo of a whisper across billions of miles. These signals revealed something no one had expected. The spacecraft were not moving exactly where the calculations said they should. The anomaly was small, almost laughably so. Both Pioneer 10 and 11 appeared to be slowing down ever so slightly, as though an invisible hand were tugging on them from the far reaches of the cosmos. The effect was tiny, barely noticeable at first, but consistent. The longer NASA tracked the probes, the clearer it became. Something was wrong. For engineers and scientists, the Pioneer anomaly became a riddle that refused to be solved. The spacecraft had been designed with extraordinary precision. Every thruster firing, every gravitational assist, every ounce of fuel had been measured, accounted for, and recalculated. Yet here they were, drifting off course by just enough to ignite decades of debate. Some suggested it was heat. The spacecraft's power source, a radioisotope thermoelectric generator, released small amounts of heat as it decayed. If the heat radiated unevenly, it might push against the spacecraft like a tiny cosmic engine. Others proposed gas leaks, uneven emission of photons, or even flaws in the tracking data itself. Still, the explanations never fully satisfied everyone. And then came the wilder theories. Could the anomaly be evidence of a new force of nature, some hidden feature of gravity we had yet to discover? Was there an unseen mass tugging from the outer solar system, a planet, a cloud, or something stranger still? In an age before dark matter became a household phrase, the Pioneer anomaly hinted at the possibility that the universe held secrets beyond our equations. For decades, the mystery lingered. Pioneer 10, launched in 1972, continued to send signals until 2003, when it was nearly 12 billion kilometers away. Pioneer 11 had gone silent much earlier, in 1995, but its data remained part of the puzzle. Long after their instruments had shut down, the question of their strange motion remained alive in journals, conferences, and late-night debates. Eventually, in the early 2010s, careful reanalysis of decades of data pointed back to the most mundane explanation: heat. The waste heat radiating from the spacecraft systems had been pushing them, ever so gently, like a slow and steady breeze. It was a triumph of patience and physics, but for many, the resolution felt bittersweet. The magic of the anomaly had suggested the possibility of something greater, something new, something alien. In the end, it seemed to be only the ghost of engineering details. And yet, the story is not so simple, because what the Pioneer anomaly revealed was not just a quirk of machinery, but the fragility of our knowledge. Even in the vast silence of space, with no atmosphere, no storms, no oceans, a spacecraft could surprise us. A tiny shift in trajectory, no more than the width of a coin each year, had unsettled decades of certainty. It is worth remembering, too, that the pioneers carried more than instruments. Like the Voyagers after them, each bore a message, a plaque designed by Carl Sagan and Frank Drake. Etched into gold anodized aluminum, it showed a man and woman, the outline of the spacecraft, and the position of our sun among pulsars. It was humanity's greeting card, drifting silently into the void, carried on two fragile machines that refused to behave exactly as expected. The Pioneer anomaly remains a lesson, a reminder that even in the most carefully planned journeys, the universe still has the power to surprise us. Whether caused by heat or something yet undiscovered, the anomaly echoed a truth at the heart of exploration, that the cosmos is not obliged to follow our rules. And perhaps, in the faint drift of two ancient spacecraft, we glimpsed just how little we truly know about the dark between stars. Chapter 4: Echoes of the Big Bang, 1992. In 1992, NASA announced a discovery that changed the way humanity understood the universe. It began with a satellite called COBE, the Cosmic Background Explorer. launched in 1989 with a mission both bold and delicate. Kobe's task was to listen for the faintest whispers, the lingering glow of the Big Bang itself. For decades, scientists had suspected that such a signal existed, but no one had yet been able to capture it with certainty. The theory went like this. Nearly 14 billion years ago, the universe began in a blinding instant of creation, an explosion not of fire but of space itself. In that first fraction of a second, energy and matter were fused together in a violent dance, and as the universe expanded and cooled, a faint afterglow was left behind. Over billions of years, that glow had stretched into the microwave part of the spectrum, a quiet sea of radiation filling every corner of the cosmos. This cosmic microwave background was predicted, but could it be observed? That was the challenge. Earlier attempts had already hinted at its existence. In 1965, Arno Penzias and Robert Wilson accidentally discovered a strange hiss of radio noise coming from every direction of the sky, no matter where they pointed their antenna. They thought it was pigeon droppings at first, but soon realized they had stumbled onto something extraordinary, the first detection of the cosmic background radiation. Yet the details remained out of reach. The hiss was there, but it was uniform, like static. To truly understand the universe's origin, scientists needed to see if this radiation had tiny variations, ripples that might reveal how galaxies first formed. That was where Kobe came in, with instruments cooled to extreme temperatures, designed to measure radiation with unprecedented precision. Kobe scanned the heavens. For nearly 3 years it gathered data, mapping the faint microwave glow left over from the Big Bang. And in 1992, the results were revealed. When George Smoot, the lead scientist, stood before his peers and showed the first maps, the room fell silent. The images displayed tiny variations, minute differences in temperature, mere fractions of a degree, but enough to confirm what theory had long predicted. These ripples were the fingerprints of creation, the seeds from which galaxies, stars, and planets would eventually form. Smoot famously said it was like looking at the face of God. That line made headlines, but the weight of the discovery went far beyond poetry. For the first time, humanity had seen evidence of the structure of the early universe, frozen in light that had traveled almost 14 billion years to reach us. The discovery electrified not only scientists, but the public. Newspapers called it the discovery of the century. For physicists, it was a vindication. The Big Bang was no longer just a theory supported by circumstantial evidence. Now there was a map, a picture of the infant universe drawn in microwaves across the night sky. And yet, what made it all the more humbling was the quietness of the signal. These echoes were unimaginably faint, weaker than a whisper heard across continents. Kobe had to filter out the noise of Earth, the interference of our own planet's radio chatter, and even the radiation of the spacecraft itself, to glimpse the true signal. To catch the whispers of creation, it took patience, precision, and decades of work. The implications were profound. Those tiny ripples revealed that the early universe was not perfectly smooth. There were denser patches, small regions where matter had begun to gather under gravity's pull. Over billions of years, those clumps grew into stars, galaxies, and eventually the web-like structure of the cosmos we see today. Without those ripples, there would be no planets, no life, no observers like us to ponder the sky. Kobe's discovery opened the door to even greater missions. Later satellites like WMAP and Planck would refine the map with stunning detail, measuring the universe's age, composition, and geometry with breathtaking accuracy. But it was Kobe that lit the path, that proved the whispers were real. Today, when we look at the cosmic microwave background, we are seeing a snapshot of the universe when it was just 380 years old, a baby picture of everything we know. Every star that burns, every planet that spins, every signal we've ever recorded, All of it grew from those faint ripples in the ancient light. The echoes of the Big Bang are still there, spread across the sky, surrounding us always. Not loud, not obvious, but patient and eternal, waiting for the instruments precise enough to hear them. In 1992, humanity finally did, and in that faint, static-filled glow, we caught our first true glimpse of the origin story of the cosmos. Chapter 5: The Mysterious Bursts. 1997. In 1997, the universe seemed to speak in flashes. Astronomers and scientists had long been aware that space was not silent. But that year, instruments captured a phenomenon so powerful and fleeting that it immediately captured the attention of the scientific world. Satellites designed to observe high-energy cosmic events began detecting sudden, intense flashes of gamma radiation. These flashes were unlike anything anyone had seen before. They appeared without warning in the darkest reaches of space, often billions of light-years away, and lasted only a few seconds. Yet in that brief instant, the energy released was greater than what our sun could produce over the entire span of 10 billion years. The first alerts triggered a flurry of activity among observatories worldwide. Telescopes and detectors trained on the regions of space from which the bursts had emanated. Each flash was a puzzle piece in a vast cosmic mystery. Scientists scrambled to understand not only what caused these bursts, but why they seemed so random, so fleeting, and so powerful. The bursts appeared in every direction, without repetition, making predictions impossible. Observers felt as though the universe itself were tapping humanity on the shoulder, offering glimpses of its violent and chaotic processes. The gamma-ray bursts challenged the very limits of human understanding. They forced scientists to confront phenomena far beyond anything achievable on Earth, revealing the extreme forces at work in the cosmos. Some bursts were accompanied by afterglows in X-ray and visible light, faint echoes that lingered for hours or days after the initial explosion. These afterglows offered vital clues, allowing astronomers to trace the origin of the bursts to distant galaxies, some billions of light-years away. Each detection was not only a measurement but a story, a narrative of death and creation on a scale almost unimaginable. Theories about the bursts' origins began to proliferate. One leading idea suggested that gamma-ray bursts were the death cries of massive stars, collapsing into black holes in violent explosions that sent jets of energy shooting into space at near-light speed. Another theory proposed that the bursts resulted from collisions between neutron stars, ultra-dense remnants of dead stars, merging in cataclysmic events that released unimaginable amounts of energy. Each theory painted a picture of a universe alive with violent transformations, where stars were born, lived, and died in spectacular fashion. For astronomers, the bursts were both a challenge and an inspiration. They represented opportunities to study the universe at its most extreme, to peer into the very processes that shape galaxies and sculpt the cosmos. Teams of scientists stayed awake night after night, poring over data, tracking the bursts' afterglows, analyzing their spectra, and searching for patterns. They worked tirelessly, knowing that each burst could reveal something new about the life cycles of stars, the behavior of matter under extreme conditions, and even the nature of gravity and energy itself. The mysterious bursts were also a lesson in patience and perseverance. Many flashes were so brief that if instruments were not precisely tuned, the events would pass unnoticed. Others left only the faintest traces, like whispers of a cosmic conversation just out of reach. Scientists learned to anticipate the unexpected, to adapt quickly, and to collaborate globally, pooling data from satellites, ground-based observatories, and radio telescopes to piece together the fleeting story of each burst. Beyond the scientific analysis, there was a profound sense of wonder and awe. Humanity was catching fleeting glimpses of events that had unfolded billions of years ago in galaxies unimaginably distant. Each burst was a messenger from the early universe, a fragment of cosmic history traveling across time and space to reach our instruments. The sheer scale of the energy involved, the distance it traveled, and the precision with which it was detected were humbling reminders of how small and fleeting human life is in comparison to the vastness of the cosmos. The mysterious bursts also inspired questions about the unknown. Could some of these bursts conceal phenomena even more extraordinary than star deaths or neutron star collisions? Could they be signals of processes we have yet to imagine? Every gamma-ray flash was a reminder that the universe is full of surprises, that its story is still unfolding, and that humanity is only beginning to listen to its language. As the years passed, astronomers continued to refine their instruments and techniques, uncovering new bursts and learning more about their characteristics. They mapped the locations of these events across the sky, analyzed their energy outputs, and tested models to understand the mechanics behind them. Each new detection expanded humanity's understanding of the cosmos while deepening the mystery. Even today, the mysterious bursts are a source of fascination, a symbol of the unpredictable, awe-inspiring power of the universe. They remind us that the cosmos is not silent, that even in the darkest reaches of space, there is movement, energy, and life in its most extreme forms. These fleeting flashes are like messages from across the universe, each one carrying the weight of billions of years and the echoes of unimaginable forces. For those who watch the skies, the mysterious bursts are a constant invitation to wonder, to explore, and to dream. Chapter 6. A Star That Flickered Strangely. 2015. In 2015, NASA's Kepler telescope trained its instruments on a distant, unassuming star in a quiet sector of the Milky Way. At first, it seemed ordinary, a faint point of light among countless others, but soon astronomers noticed that it did something entirely unexpected. The star's brightness would dip at irregular intervals, sometimes barely perceptible, other times dramatically, as if unseen objects passed in front of it. The star, later nicknamed Tabby's star, did not pulse like ordinary variable stars. Its flickers were erratic, puzzling, and mesmerizing. Scientists meticulously analyzed the star's light curves, tracking every subtle dimming and recovery. Each anomaly defied known stellar behaviors. Patterns that should have been predictable, instead, appeared chaotic. The dips in brightness sometimes lasted days, sometimes weeks, and did not follow a repeating rhythm. This unpredictable behavior left astronomers questioning their understanding of cosmic phenomena. What could cause such strange light fluctuations? Dust clouds, swarms of comets, or something far stranger? The media quickly picked up on the mystery. Headlines speculated wildly, suggesting alien megastructures or distant civilizations manipulating the star's light. Some scientists cautiously entertained these ideas while stressing that natural explanations were far more likely. Yet the idea of a massive technological construct orbiting a distant star captured public imagination, drawing attention from amateur astronomers, writers, and curious minds worldwide. Professional astronomers intensified their observations. Observatories around the globe coordinated to monitor Tabby's star continuously, using spectroscopy, infrared imaging, and other advanced techniques. They searched for heat signatures, cosmic dust, and any other phenomena that might explain the irregular dimming. Each new dataset was meticulously analyzed, revealing complex patterns and subtle anomalies that deepened the mystery rather than resolving it. Beyond the technical work, the star's erratic behavior sparked philosophical contemplation. What could it mean for life elsewhere in the universe if such a phenomenon were artificial? Could intelligent beings manipulate stars on massive scales, or was this a reminder of nature's infinite creativity? These questions inspired both wonder and humility. Humanity had long sought answers in the night sky, But Tabby's star reminded us that the cosmos often answers in ways we cannot yet comprehend. Even as researchers debated explanations, the star continued its enigmatic performance. Brightness would dip sharply, then recover gradually, then dip again, as if the star were performing a subtle, celestial rhythm. Some dips were shallow, mere fractions of a percent, while others were astonishingly deep, a dramatic reduction in light that could not easily be dismissed. Scientists modeled countless scenarios, from vast swarms of comets to uneven interstellar dust, yet no single explanation accounted for all observed behavior. Social media and online forums exploded with speculation. Amateur astronomers shared observations and theories, some grounded in physics, others fueled by imagination. Communities debated the possibility of alien technology, while others meticulously explored natural phenomena, considering every gravitational, magnetic, and orbital factor that could influence the star. The discussions were heated, passionate, and global, reflecting humanity's collective fascination with the unknown. Tabby's star also inspired art, literature, and science fiction. Writers imagined civilizations capable of harnessing stellar energy, constructing orbiting megastructures, or sending signals across the void of space. The star became a symbol of the delicate balance between science and speculation, the unknown and the knowable, the limits of human understanding. Its flickering light invited us to wonder, to imagine, and to question. Years of observation revealed subtle clues. Slight color changes suggested the presence of dust, yet the amount and behavior of this material could not fully explain the irregular dimming. The mystery deepened as researchers published papers, refining models, and exploring new possibilities. Each discovery opened further questions, demonstrating the universe's complexity and our own limitations in understanding it. Even today, Tabby's star remains under scrutiny. Telescopes continue to observe its light, capturing every dip, every irregular flash, every subtle anomaly. Scientists remain vigilant, gathering data, refining theories, and considering new possibilities. The star flickers in quiet defiance, a distant cosmic puzzle that challenges our assumptions, ignites our imagination, and reminds us that in the vast expanse of space, some mysteries are meant to endure, lingering across light years and centuries, waiting for minds capable of unraveling them. The flickering star is a whisper from the universe, a soft pulse across unimaginable distances, inviting us to listen, to wonder, and to continue the search for understanding among the stars. Chapter 7. The Repeating Signal, 2016. In 2016, astronomers detected something that would capture the imagination of scientists and dreamers alike. A fast radio burst appeared, but unlike the countless others that had vanished after a single, fleeting pulse, this one returned repeatedly. Each pulse was brief, lasting only milliseconds, yet it carried energy that had traveled billions of light years, crossing galaxies and cosmic voids before brushing past our tiny blue planet. The rhythm was like a distant drumbeat in the silent symphony of space, patient, insistent, and unyielding. At first, the observatories that recorded it were cautious. Instruments were recalibrated, equipment was double-checked, and the data was scrutinized for errors. The pulses kept coming, confirming what no one wanted to dismiss. The signal was real, and it was repeating. Fast radio bursts had puzzled astronomers since their discovery, but repetition added a layer of mystery. Repeated signals implied some kind of pattern, something that might hint at the mechanics behind their origin. Was it a natural phenomenon, or could it be artificial, created by an intelligence far beyond our comprehension? The source of the repeating burst lay in a distant galaxy billions of light years away, so far that the light from that place had taken almost the entire age of the universe to reach Earth. Each pulse carried more energy than the sun emits in an entire day, yet by the time it reached us, it was barely perceptible, a whisper amidst the cosmic noise. Scientists theorized about magnetars, neutron stars with magnetic fields so intense they could twist space-time itself, or about exotic matter and plasma interactions, phenomena that might explain the bursts without invoking intelligent life. But nothing fit perfectly. Worldwide, astronomers coordinated their observations. Telescopes in Australia, China, Europe, and the United States trained their antennas toward the source, capturing every pulse, logging every detail. Advanced algorithms ran continuously, searching for hidden patterns, sequences, or codes within the signal. Amateur astronomers and citizen scientists joined the effort, combing through data, sharing insights online, and adding to the growing sense that this was a discovery bigger than any single team could handle alone. The public fascination grew as news spread. Headlines speculated on the possibility of communication from extraterrestrial life, while scientists cautioned that no evidence yet confirmed anything artificial. Still, the story captured imaginations. Social media threads filled with theories, ranging from highly technical astrophysical explanations to bold guesses about alien civilizations. The repeating signal became a symbol of cosmic mystery, a reminder of how much humanity had yet to understand. The implications of the repeating bursts stretched beyond mere curiosity. If natural, they suggested previously unknown physics at work, perhaps a new class of celestial objects or an unexpected cosmic process. If artificial, they hinted at the existence of life capable of sending messages across unimaginable distances, a civilization that might have developed technologies incomprehensible to us. Either way, the repeating signal challenged assumptions and invited wonder. Each pulse became a moment of connection, a whisper from the universe that demanded attention. Researchers studied variations in frequency, intensity, and timing, seeking a pattern or regularity that might offer a clue. Yet, despite decades of observation, the source remained elusive, hidden behind billions of light-years of dark space. The mystery persisted, a puzzle both tantalizing and humbling. Beyond the data and analysis, the signal inspired a sense of human unity. Across continents, people looked up at the night sky and wondered if they were hearing the universe speak. Philosophers and writers pondered the meaning, imagining distant civilizations listening back, while engineers and scientists debated technical explanations with fervor. The repeating signal was a reminder that the cosmos is vast, unpredictable, and often far stranger than anyone could imagine. In the quiet of observatories, nights stretched long as astronomers watched, listened, and recorded. The signal repeated again and again, sometimes minutes apart, sometimes with hours in between, a cosmic heartbeat against the silent backdrop of space. Its repetition was a message of patience and persistence, a rhythm that the universe itself seemed to beat, reminding humanity that some truths require time, attention, and awe to comprehend. The repeating signal of 2016 remains one of the most enigmatic phenomena in modern astronomy. It challenges our understanding of the universe, invites speculation about life beyond Earth, and continues to inspire the dreamers and thinkers who listen for the faintest echoes from the stars. It is a cosmic riddle, beautiful in its simplicity and staggering in its scale, a whisper from the distant unknown, patiently awaiting discovery. Chapter 8, Breakthrough Listening, 2017. In 2017, the world of astronomy entered a new chapter in the search for understanding the cosmos. Telescopes around the globe began working together in unprecedented coordination, focused on the repeating fast radio burst discovered the previous year. What had once been isolated pulses captured by a single instrument were now observed simultaneously from Australia, the United States, Europe, and Asia. Every telescope became a participant in a quiet symphony of cosmic observation, a global effort to capture, record, and understand a signal that had traveled billions of light years to reach Earth. The repeating bursts were strange in their pattern and intensity. Some came in rapid succession, almost like a staccato rhythm, while others arrived after hours of silence. Researchers pored over the data, searching for hidden patterns, mathematical sequences, or fluctuations that might suggest an artificial origin. The pulses themselves were brief but powerful, carrying more energy than the sun releases in a single day. As the data accumulated, it became clear that the bursts were not random. They had structure, hints of timing and spacing that begged interpretation, teasing scientists with the possibility of a cosmic message. Each observation session became a blend of meticulous science and quiet awe. Teams would sit for hours in dimly lit control rooms, eyes fixed on monitors, as the signals arrived from the depths of space. Engineers calibrated equipment with extreme precision, ensuring no interference from earthly sources could mask the delicate pulses. Meanwhile, astronomers and theorists debated potential explanations. Could these be the emissions of a highly magnetized neutron star, or the result of exotic matter in a distant galaxy? Or was it something entirely unknown, perhaps even artificial, a message from an intelligence so advanced it could traverse intergalactic distances with signals designed to survive the journey? The more scientists listened, the more the bursts seemed to speak. Rhythms appeared to emerge from the chaos, patterns repeating with subtle variation. Sudden silences were as telling as the pulses themselves, moments where the universe appeared to hold its breath. Some researchers suggested that these interruptions might be the result of intervening cosmic material, a natural filter in the vast interstellar medium. Others speculated on more intentional causes, imagining civilizations communicating in a form far beyond human comprehension. Public fascination grew alongside the scientific endeavor. Documentaries, articles, and social media posts explored the repeating bursts, inviting everyone to consider the mysteries of the universe. Though no definitive evidence of extraterrestrial intelligence emerged, the signal captured imaginations worldwide. For a moment, humanity collectively looked up at the stars with wonder, pondering the possibility that the cosmos was far more communicative than previously believed. Technological advances played a crucial role. Artificial intelligence algorithms analyzed terabytes of data, searching for correlations that might escape human perception. Machine learning models attempted to detect underlying sequences, seeking any hint of purpose or pattern. Nights stretched into early mornings as astronomers followed the cosmic pulses, adjusting instruments and recalibrating sensors with relentless precision. It was a patient vigil, a dialogue across time and space, with humanity listening for the faintest whispers from the distant unknown. The bursts, while mysterious, also deepened understanding of the universe itself. By studying how the signals were affected by the material they passed through, scientists could map the density and composition of intergalactic space. Each pulse became a probe, revealing the invisible scaffolding of galaxies, clouds of gas, and cosmic dust that filled the void between stars. In this way, the repeating signal became both a question and a tool, a cosmic puzzle with practical scientific value, revealing secrets of the universe as it teased minds with its origin. Every detection added layers of intrigue. The bursts were not identical, showing variations in strength and frequency. Some traveled across regions of space that were almost empty, while others passed through turbulent clusters of stars. These subtle differences offered clues about the journey of the signal, its interaction with cosmic forces, and the vast distances it had crossed to reach our fragile blue planet. Scientists meticulously logged every variation, building a detailed record that would become essential for future study and analysis. Yet, despite the data, the essence of the repeating signal remained elusive. Its origin was hidden, its intent unknown. Was it a naturally occurring phenomenon, a remarkable alignment of astrophysical conditions that happened only once in billions of years? Or was it something deliberate, a cosmic tap on the shoulder, a gentle knock from beings capable of creating signals that could outlast galaxies? The line between science and imagination blurred, leaving humanity suspended between certainty and wonder. As observers listened and recorded, a sense of shared discovery emerged. Across continents, different teams studied the same pulses, comparing notes, theories, and interpretations. Conferences and online collaborations flourished, uniting people from every background with a shared purpose: to understand the voice of the cosmos. Even as technology advanced, the wonder remained human. The act of listening, of waiting in silence for a faint signal from an unimaginable distance, reminded people that the universe is not just vast, but filled with mysteries waiting patiently to be discovered. The repeating signal of 2017 remains one of the most captivating enigmas of modern astronomy. It challenges assumptions, inspires dreams, and embodies the profound curiosity that drives human exploration. Each pulse, brief as it is, echoes across time and space, a subtle reminder that the cosmos is alive with secrets and that the search for understanding is as infinite as the universe itself. Chapter 9: The Interstellar Visitor, 2017. In 2017, a mysterious visitor entered our solar system, unlike anything astronomers had seen before. It was a long, thin object, moving at incredible speed and on a trajectory that suggested it came from beyond the sun's domain. Scientists named it Oumuamua, borrowing from the Hawaiian word for scout or messenger. Its arrival was unexpected, a silent traveler that had crossed the vast emptiness of interstellar space to appear. Briefly, in our cosmic neighborhood, telescopes worldwide turned to track Oumuamua, a flicker of light against the vast black canvas of space. Its shape was unlike that of any asteroid or comet observed before. Long and narrow, almost needle-like, it tumbled through space as it raced past planets and moons. Its speed was extraordinary, too fast to be captured by conventional orbital dynamics, and its path defied the patterns that govern natural celestial objects. For weeks, astronomers followed every twist and rotation, capturing as much data as their instruments could provide. The object's motion puzzled scientists. Tiny deviations in its trajectory suggested forces at work that were not fully understood. It was as if something unseen was giving it a gentle push, altering its path just enough to hint at intelligence, or at least a process beyond ordinary explanation. Every calculation, every simulation, led to more questions. Could it be a fragment of a distant planetary system? Was it an ice-covered rock, or something more exotic? The more researchers examined it, the more enigmatic it became. As Oumuamua passed through the inner solar system, radio telescopes were pointed toward it, listening for any signal, any whisper that might suggest communication or artificial origin. Days stretched into nights as astronomers scanned its faint reflections, hoping for a flicker of a response. None came, yet the silence itself was captivating. Even in its quiet, the object told a story of a lonely traveler, journeying across light years in isolation, bearing secrets that might never be uncovered. Public fascination grew as images and data were shared. Media outlets dubbed it a cosmic needle, a visitor from another world, stirring imaginations and debates. Scientists discussed it in conferences and journals, theorizing about its composition, its origin, and its incredible speed, prompting even the most conservative astrophysicists to acknowledge the possibility that the universe sometimes delivers objects that challenge understanding and stretch the imagination. Oumuamua's passage was brief but profound. As it approached the sun, the light it reflected revealed subtle changes in brightness, suggesting a rotation that was irregular, tumbling through space in a silent dance. Some proposed that solar radiation pressure could account for its trajectory, a natural phenomenon that acted like a gentle wind pushing on a sail. Others wondered whether its structure was deliberately designed to interact with light and gravity in ways that seemed intentional. Observers noted that it did not show a visible cometary tail, as most icy visitors from the outer solar system do. This absence heightened the mystery, challenging conventional models of interstellar objects. Each observation offered clues and contradictions, a puzzle of light and motion that seemed to defy simple explanation. Astronomers debated for months, analyzing every photon, every reflection, every minuscule deviation in its flight. The story of Oumuamua also became a lesson in patience and humility. Humanity had learned of this visitor only after it had entered the solar system, and it would leave before most could fully comprehend its nature. Instruments captured snapshots, data points that would be studied for decades. Yet the essence of the object, its origin, its purpose, even its composition remained tantalizingly out of reach. It was a fleeting messenger, reminding humanity that the cosmos is vast, dynamic, and full of surprises that can appear without warning. Even after it disappeared from view, the impact of Oumuamua lingered. Scientists reflected on the vastness of space and the improbability of its journey. How many other objects like it travel between stars, unnoticed, carrying secrets of distant systems? Its silent passage reignited the dream of interstellar exploration, the desire to reach out and touch objects that have traveled farther than any human-made craft, to study materials and forces that are otherwise inaccessible. The interstellar visitor became both a mystery and a symbol. It reminded astronomers, students, and the public that the universe is full of unexpected encounters, objects that arrive unannounced and depart silently, leaving humanity to wonder, imagine, and search for understanding. In the weeks and months following its observation, every calculation and every telescope adjustment became a tribute to the fleeting presence of Oumuamua, the messenger from the stars, whose journey across light years whispered to Earth a quiet story of cosmic mystery. Chapter 10. A Magnetar Speaks. 2020. In 2020, the universe spoke in a language of radio waves, reaching Earth from a remote corner of our galaxy. Deep near the center of the Milky Way, a magnetar, a star with magnetic fields trillions of times stronger than anything on Earth, erupted in a sudden, powerful burst. For a moment, its energy raced across space, traveling tens of thousands of light years to be captured by instruments designed to listen to the cosmos. The radio waves were intense, unlike anything commonly observed, and their arrival sparked a flurry of activity among astronomers around the world. Magnetars are strange and violent stars, remnants of supernovae that have compressed into tiny, incredibly dense objects. Their magnetic fields are so extreme they can twist atoms like threads, and their surfaces quake under forces unimaginable to the human mind. When this magnetar emitted its radio burst, the signal carried the story of those immense forces. It was like listening to the heartbeat of a star with power enough to shatter planets and bend light itself. The first detection was quiet, almost understated in the logs of the observatories. Then the unusual characteristics became clear. The burst was brief, yet contained layers of intricate structure flares, sudden pauses, and subtle fluctuations in intensity. Astronomers debated and cross-checked data, confirming the authenticity of what they had recorded. This was not interference, not a glitch, but a genuine voice from a distant stellar giant. Telescopes across the globe coordinated to track the source, to parse the signal and understand its origin. Every observation revealed more complexity. The magnetar pulsed rhythmically, sending waves that twisted and oscillated through space. Scientists studied the timing, the polarization, the shifts in frequency, trying to decode what this stellar voice could tell about its environment. Each pattern offered hints, clues about the star's rotation, its magnetic anomalies, and the turbulent region of space surrounding it. What made this magnetar particularly fascinating was not just its violence, but its unusual activity pattern. Unlike many magnetars that flare unpredictably, this one showed a series of pulses that repeated in a way that suggested an underlying mechanism, almost as if it had a message or rhythm intentionally structured by the forces within. Researchers mapped the pulses against existing models, searching for correlations that might reveal new physics. Some proposed that the bursts could help explain how magnetars evolve over time, shedding light on mysteries that had puzzled astrophysicists for decades. The public followed with awe as news spread. Headlines spoke of a talking star and a cosmic explosion of sound, though the true nature of the signal was more subtle and complex than a mere noise. Enthusiasts and astronomers alike were drawn into the story, captivated by the idea that even natural phenomena could communicate across the void in ways that resonated with human curiosity. Each pulse carried secrets. The energy released by the magnetar's burst was enormous, equivalent to what our sun emits over hundreds of thousands of years. Yet, by the time it reached Earth, it was reduced to faint radio waves detectable only by specialized instruments. Still, those faint echoes told a rich story of cosmic forces, stellar evolution, and the extreme environments that exist in the universe. Every spike in the signal, every momentary silence, became a window into a realm few humans could ever physically witness. Researchers worked tirelessly to compare this magnetar's behavior with previous recordings from similar stars. They noted slight differences, subtle variances in pulse duration and energy distribution that suggested each magnetar is unique, a singular entity with its own rhythm and history. They theorized about the dense crust of the star, the twisting of its magnetic field lines, and the storms of plasma that might be released in these sudden outbursts. For weeks, the world of astronomy was captivated. Conferences, research papers, and online discussions flourished as scientists sought to understand whether the pulses were purely natural or if there were deeper patterns waiting to be uncovered. Every data point was scrutinized, every anomaly recorded, with the knowledge that even minor details could reveal new insights into the extreme physics of magnetars. This magnetar's signal was more than just a burst of energy. It was a reminder of the universe's scale, power, and complexity. It demonstrated that even seemingly quiet corners of space could erupt with astonishing phenomena, communicating with Earth across light years, bridging the gap between the incomprehensible vastness of space and our small, listening instruments. Astronomers reflected on the philosophical implications. Here was a star, billions of kilometers across, and trillions of times more magnetic than anything familiar, transmitting signals shaped by the fundamental laws of physics. To witness and interpret these signals was to participate in a cosmic conversation, one that transcended human lifespans and planetary boundaries. It was a dialogue of energy, motion, and light, the natural universe speaking in rhythms we could finally detect and begin to understand. As the burst faded and the magnetar returned to its quieter state, the signal left a lingering sense of wonder. Humanity had glimpsed the extraordinary forces at play in our galaxy, reminded once again that even the most distant stars could speak in their own language across the unending reaches of space. The magnetar had told its story, brief yet profound, and the echo of its voice would be studied, measured, and marveled at for decades to come, a testament to the strange, beautiful, and sometimes mysterious universe we inhabit. Chapter 11. The Nearby Signal. 2021. In 2021, the quiet deserts of Western Australia became a listening post for the universe. Among the red sands and sparse vegetation, an array of sensitive radio telescopes pointed skyward, tuned to catch whispers from the stars. It was in this stillness that a narrow, clean signal appeared, coming from the direction of Proxima Centauri, the nearest star to our Sunday. For months, the The signal persisted intermittently, subtle yet distinct, carrying the promise of a cosmic secret waiting to be uncovered. The scientists monitoring the array were initially cautious, trained to differentiate between natural phenomena, equipment interference, and genuine extraterrestrial signals. But this one stood out. It had clarity, a consistent frequency, and a precision that suggested intention rather than randomness. Each pulse seemed deliberate, measured, like a tap on a window from across the void. The signal was brief, only a few seconds at a time, yet it returned frequently enough to keep the observers awake during long nights of meticulous recording. As word of the detection spread quietly through the astronomical community, the excitement grew tempered with skepticism. Proxima Centauri is a red dwarf star, small and relatively cool compared to our Sun, but it has been known to emit flares that could mimic artificial signals. Researchers debated and cross-checked every possible source of interference. Could it be a satellite passing overhead, a malfunction in the equipment, or a faint whisper of a natural cosmic phenomenon? Each explanation was examined, and yet the signal persisted, unyielding and enigmatic. The signal's characteristics fascinated those listening. It pulsed in patterns that were unlike typical cosmic noise, and the intervals between pulses hinted at complexity. Some scientists speculated about natural astrophysical causes, like rotating neutron stars or magnetic field interactions, but nothing quite fit. Every time the signal returned, it invited more questions than answers, a puzzle that stretched both the imagination and the analytical skills of those attempting to decode it. For weeks, teams of astronomers dedicated themselves to the task, meticulously logging each occurrence, its strength, and any anomalies in timing. They synchronized with other observatories around the world, trying to rule out local interference. Each day, new data added layers of intrigue. Even mundane patterns held hidden possibilities. Could these sequences be conveying something, a natural rhythm, or perhaps a distant civilization attempting contact? The public caught wind of the signal through carefully released academic papers and cautious press statements. Enthusiasts imagined distant worlds, civilizations peering back at us, or interstellar messages encoded in radio waves. Yet behind the headlines, the scientists remained measured, wary of drawing conclusions too quickly. Space has a way of teasing those who listen, offering glimpses of wonder while keeping its true nature just out of reach. As the months went on, subtle shifts appeared in the signal. Its intensity fluctuated slightly, suggesting that the source might not be entirely stable, or that interstellar medium gas and dust between stars was influencing its path. The more they listened, the more complex the picture became. Patterns overlapped, and the tiny variations challenged the scientists to think in new ways about cosmic communication. Despite exhaustive analysis, a definitive conclusion remained elusive. Eventually, after careful investigation, it became clear that the signal was not from an extraterrestrial source, but rather a result of human interference. Nearby communications equipment and faint radio leakage from Earth-based sources had mimicked an interstellar message. For some, it was a disappointment, a reminder that even the most compelling mysteries can have mundane explanations. Yet, the lesson of the nearby signal was not one of failure. It reminded humanity of the vastness of space, of how carefully we must listen, and how easily the universe can whisper secrets that tease the mind. It highlighted the fragility and precision of our instruments, the need for collaboration, and the patience required when seeking answers in the cosmos. Each false alarm taught valuable lessons, pushing our technology and understanding forward, preparing us for the true signals that might one day arrive. Even though it was ultimately human interference, the signal sparked renewed curiosity about our nearest stellar neighbor. Proxima Centauri, with its own planets and potential for harboring life, remained a point of fascination. Researchers continued to monitor it closely, attuned to subtle changes in brightness, gravitational tugs, and any radio anomalies that might emerge. Every observation kept alive the hope that one day a genuine interstellar signal might reach our ears. The story of the nearby signal is one of tension, anticipation, and humility. It teaches us that the universe is vast and patient, often offering glimpses of wonder before revealing the full truth. As the radio waves faded and the night in Australia returned to silence, the astronomers reflected on the thrill of listening, the excitement of discovery, and the enduring mystery that surrounds the stars closest to our own. The nearby signal became a symbol of humanity's endless curiosity, a reminder that the search for connection and understanding stretches far beyond the borders of Earth, into the infinite reaches of space. Chapter 12: The Faintest Echo, 2022. In 2022, the Voyager spacecraft continued its lonely journey at the edge of the solar system. Decades had passed since it first left Earth, carrying its golden record, a message in a bottle aimed at the stars. Across billions of miles, Voyager's instruments still transmitted faint signals, whispers of human presence stretching into the void. The signals were weak, barely distinguishable from the background noise of space, yet each pulse carried the weight of a story, a reminder that even at the edge of the known universe, humanity had left its mark. Scientists at Mission Control listened intently, tuning massive dishes to capture every quiver of data. The signals were so faint that even the slightest interference on Earth could mask them. Engineers and astronomers worked tirelessly to extract the information, knowing that each byte could tell a tale of the spacecraft's systems, its environment, and its journey through the vast emptiness of interstellar space. The faintness of the signals was humbling, a stark contrast to the roar of life and technology back on Earth. Voyager's transmissions were more than mechanical updates. They were the embodiment of human curiosity and persistence, a testament to a species determined to reach beyond its cradle. Every pulse reminded the listeners that somewhere in the darkness, a machine built by Earthlings was still alive, sending home a story of endurance, exploration, and hope. It was almost poetic, a tiny artifact from our world singing its quiet song into the cosmic night, a flicker so small it could be mistaken for a star. The mission team often reflected on the enormity of what they were witnessing. The spacecraft had traveled farther than any human-made object in history, and yet it still reached back to us, bridging distances that are almost impossible to comprehend. The signal was weaker than the flicker of a candle seen across a continent, yet its presence was profound. It reminded humanity of its own smallness, yet also its capacity for great ambition. Each faint pulse was a heartbeat, a subtle yet undeniable affirmation that exploration continues, even when the pioneers are alone and silent. Voyager's path through interstellar space also offered lessons about the environment beyond the Sunday. Its instruments measured cosmic rays, magnetic fields, and the sparse particles drifting between stars. Every faint signal transmitted carried the cumulative experience of these distant conditions, translating the alien emptiness into data humans could understand. Scientists interpreted these whispers as stories about the boundary of our solar system, the interstellar medium, and the quiet turbulence of the galaxy itself. Even in its silence, Voyager prompted reflection. Observers on Earth marveled at the scale of the journey, realizing that the spacecraft was carrying not only a golden record with images, sounds, and greetings from Earth, but also decades of human ingenuity, engineering, and curiosity. It was a reminder that our desire to know and to reach out to the unknown was eternal. Each transmission, no matter how weak, carried the echo of our collective ambition, a message that we had existed and dared to explore. The faint signals also inspired philosophical contemplation. What would become of these pulses in the vast stretches of space? Could they be received by some distant civilization? Would anyone ever hear the golden record, decipher the patterns, or understand the stories we left encoded in sound and symbols. The thought that our whispers might one day reach another intelligent mind was a quiet, almost spiritual reassurance that the universe was listening, even if it did not respond. The faintest echo became symbolic of patience, endurance, and hope. It demonstrated that even in the quietest corners of space, a voice can persist. Voyager's call was not dramatic or loud. It did not demand attention. It simply existed, a testament to the long arc of exploration and the courage to venture into the unknown. And in that quiet persistence, humanity found inspiration, a reminder that no matter how vast the distance or how faint the signal, the desire to explore and understand never fades. In mission control rooms, scientists documented the signal meticulously, comparing data across decades and ensuring that every nuance was captured. Each team member understood the uniqueness of the moment, a spacecraft built in the early 70s still speaking to its creators across unimaginable distances. This ongoing connection forged a bridge across time and space, linking generations of humans to a tiny probe still journeying through the cosmos. The story of Voyager and its faintest echo is one of wonder and reflection. It teaches that even the smallest signals can carry immense meaning. It reminds us that exploration is not always about immediate results, fame, or recognition. Sometimes it is about leaving a trace, a quiet testament that we reached, we dared, and we listened. And in that faintest echo, across the silent void, humanity's voice still resonates, a reminder that curiosity and wonder are endless, and that even the faintest whisper from the edge of the solar system can carry the weight of a civilization.